Hey guys, this is my reassessment on work energy. I chose number 14 from the book, and the question asked states, Sam pushes a 10 kilogram sack of bread flour on the frictionless horizontal force of 2.0 newtons starting from rest. What is the kinetic energy of the sack after Sam has pushed it to a distance of 35 centimeters? And what is the speed of the sack after Sam has pushed it a distance of 35 centimeters. So I have my known values here, and I have my picture of Sam pushing the flour bag across the surface. Mass of the flour is 10 kilograms. Force he's putting on it is 2.0 newtons, and the distance is 35 centimeters. So the first part asks for the kinetic energy of the sack after Sam has pushed it to a distance of 35 centimeters. So all that is its work is equal to the change in energy. Kinetic energy formula is force times distance. So you can just multiply 2.0 newtons being the force times, I converted the centimeters to meters just because it'd be easier to get the joules. So it gives me 0.7 joules as the kinetic energy that it took to push this sack of flour a distance of 0.35 meters. And then from there, the second part asks, what is the speed of the sack after Sam has pushed it a distance of 35 centimeters? So what I did here was I just did the kinetic energy formula, which is equal to 4 times distance, which is also 1/2 mv squared. So I do 1/2 mv squared final minus 1/2 mv squared initial. The initial being 0, so that can just be crossed out, or I like to put a placeholder there. So my formula gives me 1/2 mv squared final minus 0. So I can plug in for FD is equal to 1/2 times 10 kilograms times v squared. So then I want my velocity of that. So what I would do is I would divide both sides by 1/2 10 kilograms, and doing so would give me 2 times 0.7, which is the force that I found earlier in the problem. And so it'll give me the square root of 2 times 0.7 over 10.0 kilograms, which would give me a velocity of 0.14 meters per second.